This is the video for the Unit 2 test review. So we can brighten that a little bit. There we go. All right, so the first part of the review here is just reviewing the algebraic rules for each of the transformations that we have learned about in Unit 2. And just as a kind of a precursor to this video, the most important thing that you need to know about Unit 2 is what is a rigid motion, or what I should say what a rigid motion is, which is the same thing as a rigid transformation. Which is also sometimes called an isometry. So this is what we're studying here. So what you need to know is that rigid motions, rigid transformations, or isometries, they are ways that we can transform a figure while preserving the side lengths and the angle measures. So basically the pre-image is congruent to the image. And no matter how many times we transform the figure using rotations, reflections, and translations, the pre-image is always congruent to the image. And that is essentially what we're doing in Unit 2. The other mathematical skill behind that is, can you actually perform a rotation, whether or not it is centered at the origin? Can you perform a reflection? And can you perform a translation? So, do you understand that the rigid transformations, which are these three transformations and these three only, preserve side lengths and angle measures, which means the pre-image is congruent to the image? And can you also discern those types of transformations from ones that are non-rigid? And then we'll get more into that as we work through this. So here we are looking at all of our algebraic rules. You only really need to memorize the rules for rotations, and even then, most of these things you can get away with counting on your test, whether it be on the unit assessment, classroom test, or the EOC. You can kind of get away with counting, but these are the rules if you just wanted to manipulate the coordinates. So I'm going to quickly fill these in. These should be in your notebook in some way, shape, or form. And like I said, if you don't remember them, it's not the end of the world. You just need to be able to recognize them or to count to perform the transformations on a graph. So a translation, 3 units left and 1 unit up. That's going to be I, right there. There's my algebraic rule right there, so I'm going to check that one off. A reflection over the x-axis means that the y values are going to change, so that would be B, right there. A 180-degree rotation about the origin, that means I'm going to switch the signs of the x and the y's, which is going to be G. Dilation by a factor of 3. Now, you don't need to really know about dilations in Unit 2 other than the fact that they're not a rigid motion. So if you are dilating a figure, you are either decreasing or increasing the size of that figure. So a dilation, just as a picture, so this would be an example of a dilation. It preserves the shape but not the size, okay? So we have triangle ABC here that's been dilated by a factor of 3, and we get A prime, B prime, C prime, and or triangle A prime, B prime, C prime, and you can see those are definitely not the same size, which means they're not congruent, but they're still the same shape. So all the angles are still the same there, and I've marked them on there for you so you can see that. So that would be a dilation. So because we have to maintain the proportions of the sides, we would have to multiply both the x and the y coordinate by the same scale factor. And again, all of this stuff we're going to learn more later in the year. But in terms of this, I just threw one on there for funsies. All right. A reflection over the line y equals x, that's where we're at on number 5. So if you're reflecting over the line y equals negative x, you are switching the x and the y and you're changing the sign, so that's E. A reflection over the over the y-axis means that the x values change, so that would be A. Translation, 3 units right and 1 unit down. The only other one that makes sense there is H. 90-degree rotation about the origin, that's turning to the left, and so that's the rule right there, C. A vertical stretch by a factor of 3, again, this is not one that you need to know for Unit 2. You just need to know that it's not a rigid transformation, basically. But if you think about it, if it's a vertical stretch, okay, here's an example of a vertical stretch. and you're definitely changing the shape. So we're not talking about similar figures or congruent figures anymore. And so if you're changing, if you're pulling it tall and skinny, if you think about it, what's really changing is the y value there. The x values can stay the same, but the y values are being increased by some factor. So that would be an example of a vertical stretch. So if we look at here, that would be an example of that would be k. And again, you don't need to know this for your test. It's just there as a FYI for the future. Reflection of the line y equals x would be swapping the x and the y coordinates, which is f here. So you can see I'm just swapping the x and the y coordinates there. So that's f. Horizontal stretch by a factor of 3, same thing. We're keeping the x values the same, or excuse me, we're keeping the y values the same on this one. However, we're kind of making the shape wider, so we could think of it as pulling the shape so that it is wider. So that would be an example of a horizontal stretch. So if we think about that, we would be affecting the x coordinates there with a horizontal stretch. And then last but not least, 90-degree rotation about the origin. Odd man out, there it is. That is, what did I just mark off? D. So that would be a turn to the right. So that would be D. The second part of number 1 asks you to identify each of those transformations described as rigid or non-rigid, which again is a huge element that we want to know in Unit 2. So essentially, the way I've designed this is that if I see the word translation, reflection, or rotation, because there's only one transformation in these descriptions. So if I see translation, reflection, or rotation, I instantly know that it's rigid. And if I don't see that, and if I see any kind of multiplication or division going on by something other than -1, I know it is non-rigid, which means it does not result in an image that is congruent to the pre-image as we described before. So for any of these that have one of those 3 magic words there, we know that it's going to be rigid. This is a rotation, rigid. Dilation is non-rigid. Reflection is rigid. Reflection is rigid. Translation is rigid. Rotation is rigid. A vertical stretch would be non-rigid because, again, you're changing the shape as I showed you in the picture before. Reflection, again, is rigid. Horizontal stretch, that's going to be non-rigid. And a rotation is, again, rigid. All right, there you go. Okay. Big part of what we need to know in Unit 2, the concept. All right, so now let's slide down to 13 and 14. Both of these are multi-select questions. Question 13 is asking us to choose all of the transformations that preserve side lengths and angle measures. That's just another way of saying that the pre-image is congruent to the image, okay, like we stated before. And for number 14, they're asking us to select all transformations below whose image is congruent to the pre-image. Again, just basically another way of saying choose all the transformations that are rigid, which is exactly what we just went over in the previous few problems. So if we look at number 13, we can look at all the ones that we saw up above. We saw this rule above, that's a reflection over y equals x. This is a 90 degrees counterclockwise rotation. This is a translation. And even though you might not realize it, that's actually just E is a combination of a rotation as in translation. Now, if you look at D and F, right off the bat, there's an X and the Y coordinate being added together. We haven't done anything in this unit that requires us to add X and Y coordinates together, and we haven't done anything in this unit that requires division by any number of any sort. So those are definitely just some other crazy transformation that doesn't hold congruence. For number 14, this is just asking you to identify the transformations that are rigid, which means the pre-image is congruent to the image and vice versa. So that's definitely not a dilation, because a dilation, as we just said, changes the size. So there was a dilation there. So you can see it changes the size of the shape. So that's not rigid. Reflection, rotation, and translation are the only ones there that are rigid transformations. Okay, so there's those two. On the next one, here we're going to talk about mapping. So mapping, as we defined it, it carries a figure onto itself. And mapping doesn't necessarily mean that the same point is carried back onto itself. It just means that the figure lays on top of itself. So all of the points that were in the original pre-image are also represented in the image in some way, shape, or form, even if they have a different name. So we're given a little bit of a story here. So it says figure WXYZ, shown on the graph, a reflection across the line x equals -2 would map the figure back onto itself. So they give us an example to work with, and we're going to select all transformations listed that will also map WXYZ back onto itself. All right, so I'm going to cheat here and use a little bit of my tracing paper. First thing I'm going to do is I'm going to go ahead and graph that line of reflection that's given to me in the question stem there. So I'm going to go ahead and graph that. The line x equals -2 is a vertical line that passes through -2 on the x-axis, and it looks like this. So that is the line x equals -2. And if you can see that, I can basically count 1, 2, 3 to the right and mirror that 1, 2, 3 to the left over here. W and Y lie on top of the line of reflection, which of course means they won't move, even if we were to reflect it. So that clearly lays on top of itself. Even if X and Z would be interchanged, it would still lie on top of itself. So that's an example of mapping. So let's look at some other transformations here and see if they map. Right off the bat, this is in your notes, or it should be, rotation about any point will always map a figure back onto itself. So if I go ahead and just use an example here, all right, so I'm going to do a quick sketch of this figure here using my patty paper. And if you haven't invested in some patty paper or some tracing paper, vellum, they sell it at art stores, really comes in handy when you're practicing transformations. So there's a rough sketch of my pre-image. So I'm going to put it on the point -2, -1, and I'm going to rotate it 180 degrees, like so. And I can see when I do that, the figure definitely lies directly back on top of itself. All right, so that was a 180-degree rotation about the point -2, -1. The other one that they wanted us to try was a 360-degree rotation about the point X. And so if I do that, I'm basically going to start here. I'm squaring up my patty paper to my figure, and then I'm going to put my point of my pencil on the center of rotation, and I'm going to rotate this thing all the way around 360 degrees, which is one full rotation or one full turn, and you can see it lays right back on top of itself. And in fact, if I chose any point on this figure and rotated it 360 degrees, you can see that the figure would in fact lie directly back on top of itself. So a 360-degree rotation will always work, no matter which point you choose. All right, so it's kind of a giveaway right there. So again, this one works as well. Okay, and you can see that. So A works, B works. A reflection across the x-axis. If I look at the x-axis is right here. All right, so if I just lie my patty paper on top of this and use my straight edge and basically fold this over the top of, over the mirror line here, which is the x-axis, I would have something that looks like that. And as you guys can see through the paper, that is not going to lay on top of itself because it's not lining up when I fold it over. All right, so and if I rotate this so that the x-axis is vertical, you can see that that is not a line of symmetry for this figure here. So that's definitely not going to work. It's not going to map it back onto itself. All right, so that one's not going to work. The x-axis is no good. A reflection across the y-axis is no good as well. Again, if I look at this, the y-axis is not going through the center of that shape. So if I were to reflect this over the y-axis, it would not map back onto itself. It would not lie on top of itself, in other words. So reflection over the y-axis is no good. A reflection along the line y equals x, that is a line that cuts directly through the second and fourth quadrant. So the line y equals negative x. Again, the y-intercept would be 0 if you think of it as in slope-intercept form, excuse me. And the slope is negative 1, so you can easily graph that line. And you can see that this is not a line of symmetry at all for wxyz. So that's not going to work. And the last one to try is a reflection across the line y equals negative 1. So that's going to be a horizontal line that cuts right through y equals negative 1, or negative 1 on the y-axis, I should say. So if I go ahead and graph that line, and I rotate it, all right, I can see that that line is a line of symmetry for this figure. And again, if I wasn't sure about that, I'm going to go ahead and put my patty paper back on it with my tracing. Make sure that that's clear. I'm going to take my straight edge, and I'm going to fold my figure over that line of symmetry, like that. And you guys can see that it is, in fact, laying on top of itself. It's not perfect because I just kind of did a rough sketch here, but you can see that it's laying on top of itself. But more importantly than that, if you rotate your paper so that the line of symmetry is vertical, or the line of reflection is vertical, you can see that that cuts right through that figure, and so that would be a line of symmetry for wxyz. So what's the answer to the question? The answer to the question is A, B, and F. Okay? And again, mapping is not something that we talked a whole lot about. Pretty much just if the figure lays on directly back on top of itself, then it can be considered mapping, even if the points are in different locations than what they were before. Sliding on to number 16. You need to perform a simple rotation here. We're going to rotate this segment about point X and talk about the slope. So one thing that I like to do is I like to create a fake X and Y axis when the point of rotation is not the origin, because you can already see the X and Y axes are bolded for you in that case. So there's my temporary X and Y axis. And so essentially you can just count. So if I remember that this axis is going to kind of be moved to here when I rotate it a quarter of the way to the left. So I'm going to look at this as a point of reference. So from the center of rotation here, I'm treating this like the origin. I go up 3 and left 2 to get to Y. So knowing that this axis is going to be knocked over and go to that axis, I'm going to rotate my paper so that this one's up, facing upwards in the same orientation, and I'm going to count 1, 2, 3, and left 2. And that is going to give me my image, which is Y prime. So again, you can count to figure out rotations. You can use your tracing paper, your graphing paper, whatever you have handy. If I were to square this up to the corner of my graph and put X and Y, the center of rotation is X, so that's where you're going to put the lead of your pencil. And you're going to rotate it exactly 90 degrees to the left, which means your graph will be squared up again. And you can see where the point ended up is directly where we put Y prime. So you can see that that's a very precise way for us to figure out what our rotation should be, whether or not you're using some sort of tracing paper or just simply counting. All right, so let's go ahead and graph our image. So this is X prime, Y prime right here. And then they're going to ask me a couple questions about slope. So what is the slope of XY? I'm going down 3, right 2. So that's negative 3/2. What is the slope of X prime, Y prime? I'm going up 2 and to the right 3. So that's positive 2/3. And for part C, they're asking me to draw some kind of conclusion based on their slope. So how are segment XY and segment X prime, Y prime related in terms of their slope? Well, clearly their slopes are opposite reciprocals. What do we know about opposite reciprocal slopes? That means we have parallel lines, or in this case, parallel segments. All right, so the slopes are opposite reciprocals. I'm going to abbreviate here, which means that XY is perpendicular to X prime, Y prime. And that's it. Drawing a relationship there. So now that we've shown that they are perpendicular, we can put a little right angle symbol right there. And that's it. All right, moving right along to number 17 and 18. We have triangle ABC is reflected across the y-axis, then rotated 90 degrees counterclockwise about the origin. If A is located at 2, 3, what's the y-coordinate of A prime? And we have a similar setup for number 18, but they changed the name to protect the innocent. So we have triangle XYZ, and now we have point X, which is located at the same place, but we are performing the transformations in a different order. What's going to happen? Let's see. All right, so let's start with number 17 here. So I'm going to plot A, and I'm going to use a different color there so it stands out. Let's go to Baru. We got A and X, and they want me to tell them the y coordinate only of A prime and X prime as they have listed here. All right, so what do we got to do? We got to rotate this thing, right? So again, I'm going to cheat. I'm going to count 1, 2, 3 and write 2. And if I keep in mind that rotating counterclockwise means a quarter turn to the left, so this axis is going to basically just get knocked down to this axis. So if I count up 3 and write 2 from here, I'm going to turn my paper and I'm going to count up 3 and write 2 from here, and that will give me my image. Oops, getting ahead of myself, folks. We are not rotating this thing first. What are we doing first? We're reflecting this across the y-axis. It's always important to read the directions. Let's try that again, shall we? All right. So as I said before, no mistakes were made. Nobody saw anything, and there's not a video to prove otherwise. So we're going to reflect this across the y-axis. So I'm going to treat my y-axis as my mirror line. So instead of going right 2, I'm going to go left 2 to get to A prime. Now we're going to use that trick and say that this axis gets knocked down over to the left. So from here, I'm counting up 3 and to the left 2. I'm going to rotate my paper and count up 3 and to the left 2 again, and that is going to give me my image. So that's A double prime, and there's A prime right there. All right, and so the coordinates of A double prime, which are not drawn very clearly, so I'm going to fix that. This is A double prime. So the coordinates of A double prime are -3, -2, and the y coordinate in that case would just be -2. So there's your answer. Now let's go over here to number 18. Now we're going to rotate it again. We're going to rotate it first. So we're rotating first on this one because it says rotated, then reflected, right? So we're going to do it in a different order here. So when I go to rotate this thing, this axis is going to get knocked down over here. That's kind of how I visualize it for myself anyway. So instead of going up 3 and right 2, I'm going to use this axis now as my point of reference. I'm going to go up 3 and right 2, and there is X prime right there. X prime, because it's the first transformation. And then from there, they want me to reflect it across the x-axis, the y-axis, excuse me. So the y-axis is now my mirror line. And if I look at how far to the left X prime is from the mirror line or the line of reflection, it's 3 units to the left. So I'm going to mirror that and go 3 units to the right. And there's X double prime right there. So the coordinates of X double prime are +3, +2, and there's my y coordinate right there. Now on your test, you got to be careful, right? And this is true of your unit exam and your EOC. Sometimes they'll ask you for the point. Sometimes they'll be sneakier and they'll only ask you for the X coordinate or the Y coordinate or some other obscure location. Maybe they'll ask you to graph it. So they can ask you for any little tiny piece of this information that's been presented here. Maybe they ask you for the coordinates of X prime or A prime instead of the final answer to try and trip you up and see if you can read your directions. Pay attention to what they're asking for you. In this case, we can answer any of those questions, but they only want the Y coordinate. So pay attention to that when you're taking your test. Okay? All right. On the back, they want us to state whether or not the coordinates for 17 and 18 were the same or if they were different and explain. So they were different, right? And probably the easiest way to explain why they were different was because the transformations were performed in a different order. right? No need for fancy words. That's what happened. All right, moving right along. We're almost done. We've got 4 graphs here. We got a whole lot of words here that's scaring me a little bit. So we've got 4 graphs here, and what do our directions say? Our directions say to match each graph to its sequence of transformations. So we're going to use a lot of process of elimination here. Based on the ALDs in this unit, you won't have to either perform or recognize more than 2 transformations in a row. So let's just start with number 20. Clearly, we've had some sort of reflection here. So if I were to highlight the final image to distinguish it from the pre-image, because we always want to highlight our answer here, I can see that I have DEF, I have D prime, E prime, F prime, and then I have D double prime, E double prime, F double prime. So this is the end result. That's the end result. How did I get there? I started off with this triangle DEF, did something to it, did another something to it, and now I ended up with that picture. All right? So first of all, it doesn't look like I just slid this thing because the orientation has changed. It's either been rotated or reflected. If it was rotated, it looks like we could say some kind of rotation to get from the first triangle to the third triangle, but something happened in between as well. And if I go up here and cheat and look at my answers, none of these start with a rotation. So that's not it. So it hasn't been, it's not just a straightforward translation. It's not going to start with a rotation. So that leaves us with some sort of reflection. All right? So, and if I look here, if I try to picture the line of symmetry, it looks like this is the line that I reflected it over first. I'm going to just highlight it here. So it looks like this is the line that I reflected it over, because I can tell because it goes right down the middle of those 2 figures. And if I look carefully at the x-axis, that is going directly through x equals 3. So that's the equation of my line. This is the line x equals 3. It's a vertical line that passes through 3 on the x-axis. So now I have 2 answer choices that could possibly work. Well, one of them is followed by another reflection over y equals x, and the other one is followed by a reflection over y equals negative x. So now we got to figure out, right over here, so y equals x, y equals negative x. So now we have to figure out what the line of reflection is. Well, y equals positive x is, it has a y-intercept of 0 and a slope of positive 1. So that cuts directly through the first and the third quadrants diagonally. So that would be y equals positive x. So as you can see there, if I take this triangle here and reflect it over that line, it would be somewhere over here. So that's not the correct answer. So process of elimination tells us that it must have been y equals negative x, which is a line with a y-intercept of 0 and a slope of negative 1 that could look something like this. I'm actually just going to do a dotted line here. So this is the line y equals negative x. Again, just put it in terms of your slope-intercept form. The y-intercept is 0, the slope is negative 1, so that's what the line looks like. Okay? So that looks like I've taken this figure and mirrored it over to get the highlighted figure. So the answer to at least number 20 is going to be D. All right, so we've got number 20 taken care of. Now let's go over here and look at number 21. Again, to get from ABC to A double prime, D double prime, C double prime, we definitely did more than one transformation. We could have gotten there just by a 180-degree rotation about the origin, but again, none of our options start with a rotation. So right off the bat, that doesn't work. So we must have reflected this thing a couple of times. Remember that a reflection over 2 intersecting lines results in a rotation. So we're definitely looking at 2 reflections here. And if you look carefully, you can see that we started here, then we went here, and our final image is this guy over here, which I'm going to color code in yellow. So before we got to there, it looks like we flipped it over the x-axis. And then once we got this figure, we reflected it over the y-axis, and that would give us this figure over here, okay? And of course, you could count to verify this, but as human beings, we're very good at spotting reflections and symmetry, so it's pretty easy to see. But if you wanted to verify it, you could certainly count, right? So in order to make sure this is a reflection, I'm counting the same number of units up as I am down. And here I would be counting the same number of units left as I am right. So you could very easily, very quickly verify that that is a reflection over the x-axis and then over the y-axis. And that would be A, x-axis, and then y-axis. So there you go. Now let's look at 22, right? On question 22, it looks like we did perform a translation at some point, and then has to be some kind of rotation because the whole orientation has changed here, and there's no reflections here. Nothing's been mirrored here. So it starts off with a translation to get from QRS to Q prime R prime S prime. That's pretty clear. And if I go up here and look at my answer choices, I have two of them that start off with a translation. So right now I'm looking at these two as possible answers. One of them is followed by, well, both of them are followed by a rotation. Okay, well now we have to get really, really picky about it. Okay, now we have to get real technical with it. So did we make a quarter turn, or did we turn it 180 degrees, which is halfway around the origin? All right, so let's look at our picture. All right, translation we know we got. Is this a 90-degree rotation, or is it a 180-degree rotation? So let's see if we can sort that out. So I'm gonna cheat a little bit. I'm gonna use my patty paper. I'm gonna square up my patty paper to my graph, like that. It's looking fantastical. So here's my starting picture after I've translated. So my options up here say 180 degrees or 90 degrees counterclockwise. So let's go ahead and turn this thing to the left and see what we get. So if I turn this to the left 90 degrees, that is definitely not the final image. But if I continue for another 90 degrees, you can see that that is what we end up with in the end. So it must be a 180-degree rotation based on what we just did. So the correct answer to that one is E, right there. A translation 4 units right and 4 units up, followed by a 180-degree rotation. So this one would be E, right there. Now we're gonna slide over to the last one, which is number 23. So the good news is that we have eliminated 3